For this week's mini lecture, I will be describing Fitts' law and explaining how it relates to speed-accuracy trade-off phenomenon. So to start off, Fitts' law is a human performance law specifying the movement time for an aiming movement when the distance to move and the target size are known. It was discovered and based on the work of Paul Fitts and is known to be one of the most significant laws in human performance. Fitts developed a mathematical principle relating to movement accuracy and speed. Fitts' law predicts the movement time in situations where accuracy and speed are required for persons to reach a target as quickly and as precisely as they can. To predict the movement time, distance to move, which is known as amplitude, and the target size, which is known as width, are key variables to indicate movement time. Target size describes how the accurate person needs to be, and the distance describes how fast they can be. So Fitts' law mathematically describes this relationship as mt equals a plus b log 2 and parentheses 2d divided by w. So in this case, mt equals movement time, a and b are constants, d is the distance moved, w is the target width or size, and a little side note is that the log 2 parentheses 2d divided by w provides an index of difficulty for speed accuracy skills. It's a quantitative measure of the difficulty of performing a skill that requires both skill and accuracy. The speed-accuracy trade-off describes an inverse relationship between speed and accuracy, where increase in speed equals decrease in accuracy, and decrease in speed equals increase in accuracy. Fitts' law can apply to many motor skills just like the implication of speed-accuracy trade-off. Fitts' law is able to mathematically describe motor behavior, predicting the average time it takes to perform a certain skill when influenced by movement accuracy demands. So, for example, when trying to figure out the amount of time to move a mouse cursor to a certain target point is influenced by the distance to the target and the size of it. So, if the target is bigger and it requires a shorter distance, it'll equal to faster times, where a smaller target and farther distance will equal to slower times. And in this case, it showcases basically the speed accuracy trade-off, since moving your mouse cursor to a target that's bigger doesn't really require much accuracy and makes it easier to make that movement as quick as possible. In comparison to a smaller target where it requires a bit more accuracy, since it's harder to move your cursor at such a fast pace since the target is small. Thank you.